Now, I can't do the math very well. When I was in school, I flunked math, and therefore I was told that I didn't know how to do math. Now, I'm a musician and an artist, so my mathematical circuitry up here is a little different than that stuff. I had a little lady come into the studio one time. She was a satellite engineer. She says, you know, I recognize that formula, one of those. I thought, oh, brother, I'm in trouble. I just copied it off the internet. I don't know what that stuff means. That's the whole point. Nobody does, except satellite engineers. So do I need to be a satellite engineer or an astronomical engineer to look through a telescope and see that or that? There's little Galileo right there. He's looking. That's the Dome of St. Peter. It's a huge structure. You could put a couple of hot air balloons in that thing. And this little guy is has a little telescope there. This is about perception. That's also the scale of the atom that I want to do. But when Galileo was looking through the little tube and he was looking at the rings of Saturn, well, he got the Medicis to look through that little telescope, and well, they thought that he was a sorcerer and that he was practicing witchcraft, and they, well, they put I guess a Renaissance type ankle bracelet on him, and they put him under house arrest. They thought they were being fooled. He demonstrated gravity to them, you know, just by rolling balls around and stuff and some little contraptions, and they thought he was being, you know, sly. It's not magic. It's physics. So what's quantum physics about? And now I can get excited about seeing the rings of Saturn. What's to get excited about quantum physics? To show you what I'm talking about, the Dome of St. Peter, you can put a couple of hot air balloons in there. Now, if I stick a speck of dust in the middle of that area and play that out as an atom, that's one atom, particle and wave, particle, dust, wave, that whole container where everything plays in the waves. What's playing on in there? It's crazy. For one thing, it baffled everybody. And that's part of the next segment. How do we even discover? Well, obviously we had the technology to kind of figure out what was going on down there. But the whole conundrum was we couldn't figure it out. We thought we had it all figured out. And Newtonian mechanics played out, meaning 2 plus 2 equals 4. And we expound on that. And the universe is just a big clock. And it's all predictable with past and future and all of that. Well, when we started to get the technology to even pry into that, it was very disturbing because we just couldn't figure it out. It didn't line up with Isaac Newton. This is great. So there were these principles that they discovered about it. Through the years, it took a few decades. And there was a bunch of ballyhoop about it, and Einstein wasn't going for it and all that. And it was a lot of fun. But anyway, there were these 4 principles, and I want to talk about them when we incorporate them into drawing and painting especially. And I can demonstrate them and simplify them, and we're going to have so much fun you're not going to believe this because it's real basic and vital to art. Extremely vital to art. And once you understand them and start thinking about them when you're doing your art, ooh, man, when it becomes part of your process, as any reference, right? And your experience. But when I demonstrate these four principles, and you'll see how wonderful they are when you apply them to to the art. It gives you so much power. There's so much power to them. Stay tuned. Particle wave E equals MC. Not scared of exploring this one.